Well, hello and welcome back to Wurth Live. I'm Jason, and next to me right here is Mr. Rick Akins from our machinery division over at Akins Machinery, and we will be your hosts of today's live stream. Not only do we have a great show planned for you all, Rick brought his machine knowledge, and he also brought a new friend. Rick, tell us a little bit about that stash you got there.
Hi, Jason. Hi, everyone. Thank you for being here. The mustache is not a fashion statement. I can't
Look
believe
at
you
that,
just
but
shared.
I think it is.
Oh my. But it is for men's health awareness for mental health, testicular cancer, and prostate cancer. In the month of November, a bunch of my friends grow these somewhat funny looking mustaches, and they're not funny looking on everyone, just funny looking on me. And it sparks the conversation about men's health awareness. And we're trying to kill cancer in every form of it. And we raised $15,000 last year with our organization. So that's why I have an extra caterpillar with me today.
Well, that is awesome. So we will be talking to the team over at Springa. Just to give you guys a little heads up, Springa aims to give more power to the craftsmen and professionals, enhancing jobs and new market opportunities through easier access to digital fabrication technologies. And by easier, they're not kidding. They have this new product, Rick, I'm sure you're aware of it. They just launched, it's called the Goliath CNC. It's the world's first portable and autonomous CNC machine, and it's able to run large projects pretty much anywhere, anytime. What are your thoughts, Rick?
I think it's going to be a great product for us. It's so far it's seemingly working great for customers, and I'm really excited to be a part of it. And right now, Wurth is the importer for the U.S., and so I think it's going to be a good product for us, and definitely a good product for our customers.
Right. These are going to be available both at Wurth Machinery for Wurth Lewis company and over at the Akins website right there for our Bear Supply customers. And hello to all of you guys joining us. And we also have another special guest host here, Dan. So you want to tell us about yourself?
I'm Dan Christensen. I've been in the woodworking industry since 2004. I come from the machinery fabrication side. I used to build CNC woodworking machinery, but now I work for Hermance Machine, which is a new acquisition of Wurth. So our sister company is Akins. I sell machinery all over the U.S., kind of the outside territories for Hermance, and I'm pretty excited about this Goliath system as well. I think it has some good applications.
Absolutely.
Thanks for being here, Dan. Good to see you.
Good to see you.
Well, without further ado, let's join the Springa team, Lorenzo and Diletta. How are you guys today?
Hi, guys.
Hi.
We're great. Thank you.
So you're coming all the way from what? Italy, right?
Yeah.
What time is it over there? It's got to be approaching the dark.
5 p.m. in the afternoon. We're in Milano.
Sweet. So tell us a little bit about the Goliath and Springa in general, I guess, your company.
Yeah, we began the company about 5 years ago with the goal you shared. So we want to make it easier for anyone to access the digital fabrication technologies, and in particular, today we begin with the CNC technologies and manufacturing. And Goliath CNC, it's our first product. It's a portable and autonomous CNC machine, which changes the way of working with CNC technology because it's a portable robot that you can place directly on the work surface. And so instead of having a big machine where you have to place your wood panel sheet, you can bring the machine directly on the wood panel, and in that way you have a small tool that allows you to work a very large work area.
Very nice. So while we're going to be talking about this, you guys were kind enough to we're going to be running a full-on taking it out of the box, setting it up, and actually running a program. So I don't know if you guys want to start walking through this, or just you let us know what you want to do here.
Let's do it.
We wanted to share with you and to show how the Goliath system looks like from the very beginning, and from how the customers will receive it. So you can see now our Davide, which is another co-founder with me of Springa. He's helping us from our lab. So in the box you will find the robot and a few accessories. This is the power stand cable to support the power cord cable, which is another accessory, which is custom designed to work with Goliath, because it strengthen and compress based on the distance on the work area. Then you have the robot, and we will go to its details in a bit. And then you have the two sensors, which are one of the most important aspects of the whole system. We used to say that the system is made of three elements: the robot, the sensors, and the software. All of them are included in the standard in the package, yeah. Included in the price, so you don't have to buy licenses for the software. It's already included. Now we will show you how to run the setup. So which are the steps you have to run to set up the work area, and we will show you how the machine works, and we'll have a quick demo of a cut to show also the machine in real action.
Nice.
Now
looks great, and also it looks easy and simple for a powerful machine. That's those are quick, simple steps to get it out of the box, and everything looks great.
Yeah, this is one of our drivers running Springa and developing the products, because we want to make things easy for our customers. We are designers and engineers before being entrepreneurs, and so we begin this initiative firstly looking at looking at ourselves as customers, and so we design and we develop the machine with this in mind. So you can see that now Davide is fixing the sensors. So one of the steps you have to make is to fix them to the work area. The machine has to work always with the sensors. We at the moment is the best way and the unique way to let Goliath work with the precision we wanted to. We design and we develop for him, and so that's the steps. And in the video that Jason was sharing, you could also saw a little bit of the projects that we made and we realized with Goliath. We have also a few of them here with us. So we like to say that it's a tool that allows to create human scale projects. So from small signage like this one, which is the demo project that we suggest for anyone to start from by downloading it from our website, till bigger things like this coat stand, or we have a chair right there,
a
locker, so a small piece of furniture here. We are using it in the office for our backpacks and so on. And so these are a few examples of what we are creating using Goliath.
Throughout this event, Dan C and Jason and I are going to be asking some questions of Lorenzo and Diletta about the machine, because I think you two know it best. And although we're starting to know this machine really well ourselves, I think it's best coming from you, and we also want to guide the conversation for our viewers and help learn about what this is. And so my first question is while we're looking at this getting unboxed, is I see there's two towers, both on the left side, and I understand that there's also another way to reference where the Goliath is positioned. One of my questions is what is the other way of referencing the positioning of the Goliath? And also, how does the Goliath know it's the length of the board and the length of what it's its location is? Because both of those are on the left side. How does it know where the right side is?
Yeah, to know its position, Goliath works with these two sensors. Each sensor has a cable that you will see later. It's connecting to the top of the robot in a very easy way. We have a sensor with a yellow pin, and the second sensor has a gray pin, and you have both these colors on the robot, so you can't. It's very easy to match the things, so to avoid any kind of error. And regarding the position on the work area, Goliath makes with the sensors makes a triangulation. The sensors are communicating with the robot 300 times per second, recognizing the length of the cable in order to verify if the robot is in the right place. Regarding the dimension of the second side, you were asking, Rick. It's a thing you can manage and define in two ways. The way we are working today is through a manual definition. So through Slingshot, that is the third element of the Goliath system that you are seeing right now, which is the software we custom developed for the robot. You can type the length of that side. On the other way, you can also run the panel detection, and so the definition of the work area size by using the yellow sensor. And so attaching the cable to the robot and moving the sensor on let's say on the four corners of the work area. By pressing a button, it will recognize each corner, and you will see the area you detected, and so in that way you measure it.
Got it. Cool.
Yeah. Now, what we are sharing is the definition of the parameters of the project we are working. So we will cut the Würth logo. It's a small signage. So once you import the file, you have to define for each track the cutting parameters. So, for example, with which kind of milling bit you are going to cut it, and which depth of cut, and so on. And so, for example, we will use two different milling bits because you can see that the Wurth word and the Wurth logo it's gray, while all the rest is black. This is a graphic way to say that they have a different depth of cut. So the black one is a full depth cut. We are cutting a piece of plywood. It's a poplar plywood of 15 millimeters of thickness. And so once you define all the parameters, you will run into the panel detection phase, which was the one I was explaining before.
Here's a really good question. What kind of files can we use? Is it, just the usual vectors? Like, what do you guys recommend?
As of today, we can import SVG files, it's a vector format. We are working also to let Slingshot able to import directly the XF.
Got it.
Nice.
I have a question. Does the customer need to know any M&G code like a traditional CNC machine? Something I was thinking of, or is the user interface designed to where they don't need to know that?
Sorry, can you repeat then, because we missed the first part of the question.
Oh, that's fine. I'm seeing that's my second question. I'm seeing he's connecting the sensor. I want to ask you about that next. Does the customer using the machine need to know any type of code to run the machine, or is it just user-based interface? Like what I mean is M&G code. That's what we'd call it out here for on a traditional CNC machine.
The customer does not face with any code, so it's a thing we wanted to avoid from the beginning, to make the machine available also for people which have no experience with CNC machines.
That's a good aspect. A lot of people are afraid to get into CNC because of the code. It makes it a lot easier to get started.
Yeah, and also, on the other way, we have people, and we have customers with a good experience from the CNC world, and someone who likes to type the code or put hands on these more technical aspects. But it's a thing that we wanted to manage, particularly via our software. Because due to the way Goliath works, there are custom algorithms that calculates the way he's working. For example, if he has to cut a pocket, he should take in consideration that once the pocket is done, it doesn't have to move it around there to avoid to fall down into the pocket. And so that way it's not possible for the customers to on one way to use different software to generate the G code, and on the other way we do not suggest to manipulate the G code if you're not friendly with the way of Goliath works.
So, all right, and so if you're just joining us, we're start to finish making a project with this new Goliath. So out of the box, onto the plywood, all set up. So I'm guessing, is it ready to start its thing, or what's next on that?
Yeah, Davide switched on the two sensors, so you can see the yellow light blinking.
Mm-hmm.
And now I don't know where is Davide, but he will start doing the panel detection. So connecting the two sensors to Goliath, and then we will start cutting, so we can proceed with the panel detection.
Yeah, so we're not seeing him because he's at the computer doing the things we shared before.
Yeah.
Oh, okay.
Yeah, that's because the software shows a wizard that explain all the steps that the users have to do. So it's quite simple because there are images and descriptions and all the information the user needs to proceed with the panel detection without any problem.
So we have a question. Does your software manage the feeds and the speeds?
Yes. Yeah. Yes, it does. Among the parameters you have to set, there is also the possibility to define the feed rate, so the speed of the machine. It depends, of course, as a traditional CNC machine, by the milling bit you install. So you have you can choose between custom parameters or recommended cutting parameters. So if you're not friendly with the CNC, you can choose the recommended one, which are based on the milling bit you defined. On the other way, you can choose to run it, for example, quicker or slower, typing by hand the feed rate you want.
Nice.
Again,
how heavy is it? If I'm carrying it onto a job site, how heavy is it?
Excuse me, Dan?
How much does it weigh?
The machine,
the whole device in a box. As I'm carrying it onto a job site, how much am I going to be carrying?
The machine, the robot, it's 15 kilograms. The whole box, it's around 20 kilograms.
Rick just pulled out that calculator.
Yeah, let's get that into pounds for everybody. So 15 kilograms?
Yeah.
20
So
altogether, about
roughly
45 pounds.
a little over 30 pounds.
Yeah, the whole box, it's around 20, 21
Okay.
kilos.
That's 44 pounds.
Oh, got it. Okay.
Yeah, we also designed, on our website, there is a library of projects that the user can download for free to practice and to use Goliath. And you can find most of the things we have here with us. And we designed also a wooden box where you can move some of the parts. For example, the foam on the bottom that is in the box in the cardboard box where we send the Goliath. You can save some of the you can save all of the parts that are inside and move them into the box, which is the project, by the way, that it's shared in the video by Jason at the moment.
So the Goliath makes its own carrying case. That's cool.
Exactly. Yeah.
Oh,
so
that is
Goliath will make its own case in order to have something which is stronger than cardboard. In particular, if you want to bring it with you away.
Yeah, because it has wheels, and so it's quite easy to handle it.
It's great that you include some projects right out the gate for the customer, because I mean, everyone wants to be familiar before they start using it on one of their projects. So the fact that you're making it easy to practice and get to know the machine is awesome. That's really cool.
Yeah, we used to share all the details to how to make it correctly. So, for example, the box is not so simple if you look at the file, at just the file. So, for example, for that project, we created a manual, so all the users can download both the file for the project and the manual to follow all the steps.
That's great.
Yeah.
Yeah, and moreover, you can download not just the SVG file, but the project in Slingshot. So with for example, all the cutting parameters already defined. So you don't have to choose the milling bit and the feed rate and so on. It's already prepared. You just have to import the whole project. And so you're almost ready to start. And I think we are ready to start also with the Wurth logo.
All right.
Nice. Let's see it. But again, it's nice how simple you're making it. It's also nice how comfortable people can feel right away. It's which is important for such a new product that really no one's ever seen anything of its kind before.
And you're saying 30 to 40 pounds. I mean, what is a typical CNC weigh, Dan or Rick?
That would be tough to bring to a job site, because it's also I don't think you can fit that in your vehicle in any way, shape, or form either. So I mean that is non-portable.
Yeah.
Totally.
So now you see that the spindle is going on the top. In order to install the milling bit, we already installed it, but yeah, this is another of the steps that Diletta mentioned before in the wizard. Then by pressing the yellow button on the top of Goliath, the spindle will go down to make the calibration of the Z-axis. So it measures the length of the milling bit. And by pressing again the yellow button, he starts the project. So now it will start the cut. I think it will start from the engraving of the word, and then we will make the rest of the cut.
So tell me, what's the accuracy? What kind of accuracy can I expect from this machine?
Yeah, with thanks to the positioning system we described before, Goliath has a repeatability on the same pass of 0.1 millimeters. So now
0.1 millimeters is about 4 thousandths. That's a big goatee hair.
Yeah, that's
a Movember hair.
Yeah, yes, it is. That's extremely accurate and finite. That's
Look
good to
at
know.
that.
Oh, geez. Show the Goliath again.
Yeah,
You promised me you wouldn't show that, and I'll never do a video again with Jason. That's
So,
confirmed.
so this is pretty much amazing. Like I could have zero woodworking experience, take this thing out of the box, hit start, and pretty much just rock and roll. That's phenomenal.
Yeah, regarding so that was the repeatability. The accuracy depends on the distance and on how big is the work area. So it's like 1 millimeter over a meter. So if you are cutting at the maximum distance from the sensors, which is 3 meters, you can have a difference of between 1 till 3 millimeters.
So you said that was a 50 millimeter board right now that it's working on. So
Yeah.
that's about 2 inches, or sorry, half an inch. What is the 2 inches? What is the max depth of cut for the Goliath?
The usable.
It's a 15 millimeter depth board is what he said, and that's about 5/8.
It's 15.
Sorry.
15, got it. I was going to say that doesn't look like 2 inches, and I was doing the math in my head for 50, and I just misheard you. I'm sorry.
Rick, you have the
It
calculator.
happens.
I know, and here I do. I have my calculator right here for quick conversions. But okay, so a little about 5/8 of an inch. So what's our max depth of cut for the Goliath?
The usable Z-axis range is 58 millimeters.
Okay, a
Um,
little over 2 inches. Got
There
it.
we go.
Yeah, it depends on the milling bit you install. In our experience, the higher thickness we tested was 27 millimeters of beech wood. Yeah, this one it was a part of a chair. This is not plywood. This is like I think it's in English glue laminated beech. So it's like a harder piece of wood. So
Yep.
these are two parts of this foldable chair.
Yeah, this was the seat and this was a leg. So
Yeah.
So we do have a question. How does the machine reference depth of cut?
Yeah, thanks
So
to
the tool
the
came down and touched the table.
exactly then. Yeah, thanks to the Z-axis calibration at the beginning of the cut, and the depth per pass. It's another parameter that the user can set in Slingshot. So at the beginning, you can choose again between recommended or custom depth of cut, which is based on the type of and on the diameter of the milling bit you're using.
And then we got another one. Is it essential to have the computer near the CNC, or is it possible to upload a file to the cloud and work from there? And greetings from Spain. Hello there.
Oh, nice.
Yeah,
Welcome,
great.
welcome our Spanish customers.
Buenos dias.
Buenas tardes,
Yeah.
I think.
Oh, tardes. Bom dia.
It's essential to have it to run the setup. So for the first phase, in this moment, it's essential. But when the machine starts, it's completely autonomous. So you can close the laptop and go away, and hold the G code. It's hosted on the machine, and so it can work on its own. In that way, of course, you will miss the notifications from the robot. So, for example, in that moment, we are changing the milling bit because we ended the first part of the cut, and so on the software you will see a pop-up telling you have to change the milling bit. So it's that moment, and so if you close the connection between the computer and the robot at the moment, you will miss that notifications, for example.
So speaking of the bits, is there a bit specific for the Goliath? You have to purchase, certain router bits, or how does that work?
We suggest, and we, one of the things and the accessories inside the box, there is also a 1/4-inch milling bit for the US customers. We suggest to use our milling bits because are designed for the way of Goliath works, but it's compatible also with standard milling bits on the market.
That tool change was very quick and easy, and it's easy to access where you're making the tool change too. And so once I take out a bit and put in the next bit, am I hitting the button on top to restart the program?
Yeah.
Yeah.
Got it. That was easy. I'm glad we just showed
and there
that.
it touches down the table and re-references the bit.
Yeah, that's great.
The bit, right?
Very nice. So good question here. Can you use this for other materials other than wood? And hello from Tucson.
Tucson.
Yeah.
It's in Arizona.
Tucson. Well, look at that. I thought it was
Tucson.
so far away.
It's Arizona.
We love Wurth. All right. Well, Tucson. I'm.
Wow.
I need a calculator.
Jeez. Yeah, I know. We're reaching all over the country. Welcome from Arizona.
Yeah. I don't know what I was thinking. I was thinking Italy. I don't know. So yeah, what other materials have you guys, had the honor of working on other than wood?
We tested some acrylic.
Yeah.
And some soft metal too. We are currently running tests on other materials, so we are planning to have some check on PVC, for example, and some other plastics and rubbers.
Yeah, I was just thinking of something like solid surface or whatnot. That'd be kind
Or
of.
what about melamine? Can you use a push-pull bit with melamine?
Sorry?
Melamine.
Melamine.
I'm using it on melamine for like cabinets that are particle board on the inside, melamine on the outside.
It's a thing that specifically we didn't try, but again it's a thing we used to work with wood and mostly plywood, but we will run more tests to also create different projects and give more data to the customers.
I'm assuming it would do great with melamine. It's just it'll probably come down to just having the appropriate tooling running on melamine. Yeah.
So here's another one. What is the minimum length of the tip for cutting?
The tip is the bit.
Yeah.
That's what I'm thinking. Yeah, is there a certain size length that you need, I guess, for the bit?
That's a tough question because I mean, I guess it really depends on the materials we're cutting also to be able to, and how thick the materials are.
From the collector.
Yeah, I think the minimum. Yeah, I don't have a measure to say or a length to say. Sorry, but the minimum length it depends on the minimum distance that the spindle has from the bottom of the transparent spindle protection. Because at a certain point it will touch and go over the spindle protection. So I think that the minimum length it's about a centimeter, 10 millimeters. We have to check it more precisely, but to give an idea, I would say this.
So while he was changing the bits, it's a great question. What happens if the robot moves, or if you move it, or an earthquake, or who knows?
He will restart from where it has to restart. So, for example, if you, of course, it has to be inside the work area. So if you bring it and you take it out of the panel, you will receive a notification that there is a positioning error.
So if you're changing the bit and it moves like maybe like a ½ inch or so, it'll correct itself.
Yeah.
Very nice.
What's the max size of a sheet or distance the Goliath can cover on a board?
The limitation for that is the length of the cables of the tower sensors, which is 3.5 meters. So we used to say that the maximum work area you can work, it's a rectangle, let's say that whose diagonal it's 3.5 millimeters, which to make it easier, it's like 3 per 2 meters, more or less.
Got it.
That's almost a 4x8 sheet.
Yeah, it's almost a 4x8.
Look at that. Faster than Rick at a calculator. Dan,
Yeah, no, Dan, good math.
Dan's awesome.
Yeah.
Yeah, this is good. So we do have somebody say compression bit, but I'm guessing, is that just the way it's connected, similar to like a router housing? Is that a compression bit? Or they just wanted to say compression bit?
Yeah, they just
Oh, that was the word I couldn't think of when I was talking about melamine, was a compression bit.
There we go.
My brain turned off and I couldn't think of that word.
Well,
Thanks whoever put that up there for me.
Yeah, awesome.
One of my questions, so this is a little over a 1/2 inch. Let's say I think a pretty common sheet size would be 1/2 inch or even 3/4 inch for us over here in the US. How many passes would we, if we were going to cut out a part and cut all the way through, roughly how many passes for 3/4, or let's say 20 millimeters? How many passes would the Goliath need to take to be able to route all the way through the board?
Again, it depends on the diameter of the milling bit. In that way, the recommendations are the same as a traditional CNC machine. So we used to work with a depth of cut which is a half of the diameter of the milling bit. But for example, with pretty soft materials like poplar plywood, you can also have a depth of cut which is the same of the diameter of the milling bit. So, for example, using a 6 millimeter bit, it will take, I would say, 4 to 5 passes.
Okay.
Hey, there's something I'm noticing here. There is not a lick of dust on that. Whatever you're using for dust collection is working.
Great. Yeah. A good. Another thing we didn't focus on is that Goliath comes with an integrated dust collection system. Maybe Davide can show the dust, how the dust collection bin is made.
Awesome.
But yeah, you can see that it's the rear part. It's removable.
Like this. So you can empty it easily when it's full.
Exactly. Yeah.
Wow.
There it is.
Yet again, I'm being shown how intuitive and easy it is, and the enclosure around the drill bit keeps it nice and isolated for the suction. But yeah, Dan, you're right. That is a clean board.
Even looking at the wheels, there's no dust on it. That's pretty impressive.
Yeah.
So what is the horsepower of the router from David Long out there on YouTube?
I would answer in that to leave Rick able to make the conversion. It's
we're gonna lean on Dan for this conversion, I think.
Yeah, I know. Dan's quicker with math. I think he's got this in the bag.
I'm really good at pronouncing cities, obviously. So
yeah,
for
that.
How many watts is it?
It's 710 watts.
Okay, so that's almost 1 horsepower. That's
Got it.
It's over 7/8.
I mean, I think the one of the good things about this machine is to cut, a 3/4 inch board, it might take upwards of 4 passes, but also, there's no one there holding the router. There's no one there doing anything. So, I mean, it would be great for a job site. You need to cut a part that maybe you cut incorrectly in the shop. Maybe you're far away from the shop and it would be hard to go back to the shop to remake a part. It'd be great to just put this up and let it cut out parts out of a sheet while you're off doing an installation. It's so I mean, 4 passes, that's pretty good. And also the best part is no one has to stand there to hold it, to watch it, to handle it. It's doing its job all on its own.
I'm gonna get one just to start a sign shop while I'm at work. I could just be working on my business all there for Etsy.
Side action, baby.
Yeah,
Mr. Akins asked,
just don't compete with Wurth.
Yeah, no. Well, I'll make Wurth kind. Does it plug into any standard 110 volt electrical socket at anyone's house? So this is a two-parter. Thank you, Dan. That's
double question. That's
really,
my brother,
really good.
by the way. Thanks for the question, Dan.
Yeah, the answer is yes. We have two versions of the machine, one for the European market and one for the North America. And we provide with the power cable, which has the plug for the US market, and with the motors compatible with the 110, 120 volt systems.
So, I mean, it makes it great for someone that is interested in DIY or a hobbyist also. I mean, they can plug it right in their garage and be working in no time. We saw how simple that was. But I think, Jason, you hit on something. Sign shop. I mean, that was too easy to make a high quality sign. And I mean, we should be selling Wurth signs to Wurth.
Yeah, as well as you were talking, Rick, since we're just going to, talk about each other. You mentioned how, like, if you already have like a giant, CNC machine, you're flying, your boards, all your projects going to LA and you're in New York, and then, you're installing it. What happens if one of the pieces break? You just bring one of these instead of, dragging a however many pound CNC machine with you, or flying back, all that stuff. It's right there with you.
And we all know how expensive freight is nowadays. So shipping parts to and from a faraway job site is almost out of the question. So being able to just set this up somewhere at the job site and walk away, and it'll remake your part for you. And that's the job site, construction companies, installation companies, someone wanting to make signage,
multifamily homes, apartments, hotels, schools.
Yep.
Inlay in a giant wood floor in your house. You could put the nice Wurth logo when you walk in, all ready to go. I like it. So yeah, we mentioned earlier about the other materials. You guys said you're still working on like PVC, acrylics. You guys were still testing all that, or was there anything? I'm guessing anywhere a router bit will cut. I mean, this thing will probably work, right?
Yeah.
Yeah, probably.
That's a good, easy answer. What's the business plan regarding rollout in Europe? Are you looking for suppliers? Are you guys looking for suppliers? They're from Sweden. Look at that.
Sweden.
Absolutely.
It's an activity we're running also in Europe. We are already working with a few dealers in Germany in particular. But it's an activity which is
on our to-do list.
And which is currently running. So
and for the cost, it is on our Akins machinery site, Wurth machinery site. If you guys check that out on Bear or Lewis, I'm not sure exactly what the cost is, but it's probably less than half or quarter of the tax of a CNC machine, I'm guessing, or like a huge machine. I don't know. I don't even know how to put that. Rick, do you have a price on those with your calculator?
I know. I should have had that price ready to go.
It's actually a lot less expensive than a CNC machine.
Right. Just getting to see the CNC machine.
Entry level CNCs start at $50,000.
Yeah.
We're selling the machine for $4,000 in the US.
So look at that. That's a huge difference.
Oh yeah, that's 1/10 or 1/20th of most CNCs out there.
You can take off a zero from the price of a traditional CNC. Totally.
So from Greg here, can the wheel safely cross cuts that it's already made? So basically, can it run over its own path?
Yeah.
Yeah, it's one of the aspects we worked on a lot during the development. These Omni wheels are custom designed to make what Greg is asking. So you can see that are made by 3 modules, which are shifted one between the other, and in that way it ensures that at least one roller it's always in touch with the work surface, with the panel, considering a cut of 8 millimeters.
Yeah, the thick multi-directional wheels on that make it almost impossible. I mean, it would have to be a really large groove to to even feel a bump. I mean, that way it never drops down into any slots or grooves, and that's a nice design.
Yeah.
Absolutely. Here's a good question. So
you also mentioned in the beginning that the software. Oh, sorry.
Oh no, go ahead, Dan. We have all day. No, I'm kidding. Yeah, go ahead.
So he mentioned in the beginning that the reason why I use their software is it also will avoid big pockets too. It'll avoid driving over the pockets. Did I hear that correctly in the beginning? That if there's a big pocket that you could potentially fall into, it's designed to avoid that.
Exactly.
Yeah.
The software considers the best way and the best order to run the job. And so, for example, if you have a big pocket, probably it will consider to do it as a last track or last part of the job. But of course, it depends on the design and where it's placed.
So for the reference towers, can they be fastened down any other way other than screws? I'm guessing maybe double stick tape, or is there any other options?
At the moment, unfortunately not, but it's a question we received from a few interested users, particularly in the flooring industry, because it's better to not screw down something in the floor. And so it's I think based on the market request, it's another feature and maybe another accessory we can also develop if there is a request to find a way to fix the towers in a different way.
Well, Wurth does make a heck of a glue wood filler, so I mean, worst case, a little bit of wood putty in there.
Yeah, the thing is that the sensors has to be
at the same level
of the robot. So
could you use like a scrap of wood, screw it to that scrap, set it next to it, then clamp kind of somehow, or
I mean, that's the only workaround we found. So to place the sensors on an external panel that has the same thickness of the working area, so you can switch only the panel and leave the sensors placed almost affix the setup.
Mm-hmm.
But
nice.
Another feature we saw from that demo we just run. You can see that the work area is made by 3 small different panels, and the sensors are not exactly on the same sheet we decided to cut. So, for example, we could make a different design which optimize the usage of the last panel. That was to say that it's important that the sensors are on the same height of the panel we want to work, but it's not so mandatory to have them exactly on the same piece.
So what size are the bits, I guess? What's the largest you can use? Is it 1 collet size, I guess? Or how does that work as far as the diameter of the bits?
The maximum collet we can use is 8 millimeters.
Rick?
I have a weird question regarding your flooring.
So about a third of an inch.
I have a weird question regarding flooring. You got me thinking about how to use it as flooring, and I thought old technology. Could you use it like a pin router and use your top board like a template, and let it drive over the top board, and then use a longer bit to go through the board into the floor, so you don't have to screw to the floor, but use the top board as a driving template, and it drives on the top board.
Look at that, Dan now works for Springer.
And now machines through it like a pin router would in the old days. Right? In the old days, that's how we'd use a pin router to make parts. Kind of merge the CNC with the old.
Yeah, that's a good idea, for sure.
One huge question I know that everyone or at least all my customers always ask about a machine is how are we going to be able to support it? And I actually heard from a customer recently that you all did a virtual video chat to help a customer that had questions and thought he had an issue, but you ended up fixing it for him right over a video call from Italy. That's pretty cool.
Yeah, this is a thing we're not running usually, but it's one of the way we are supporting customers. Moreover, we have a live chat support. We have email support. We have a forum where the customers can find help from other customers and from us, of course. And lastly, we realize tutorials. You can find many tutorials on our YouTube channels and on our website in order to allow people and allow our customers to know better the way the machine works.
Great. I mean, and I guess the other thing that should be mentioned is between Hermance and Aikens, Hermance Machinery and Aikens Machinery, we have 9 salaried technicians on staff. And so, we're still a little new to the game, but those technicians are lethal and can fix just about any issues. And so, in the beginning, we might need to call Italy every so often with questions, but our technicians can fix anything. And in no time, we'll be able to support these very well in the US through those 9 guys, which will be great.
Yeah.
Look at that sign. I think I'm starting a sign shop.
Me and you both. Well, we'll split it. $2,000 each.
We'll split it, and then we'll split the profits. But I mean, really, we'd be up and running in day one. I already have the Goliath right out back in our shop.
Perfect timing for Mike Robertson here. When will these be available?
Now.
Yep,
they're in the US now. We have a lot of them in our shop up in New Hampshire, ready to ship at a moment's notice.
So yeah, we got Lewis and Bear,
which is pretty nice considering lead times lately. I feel like every machine right now has a 4, 5, 6 month lead time. So it's nice. That might be the first time I've said we can ship it right away in over a year. So that feels good.
So here's another question. Is there any chafing that needs to be removed after completion of cutting? So like how smooth, I'm guessing they're asking how do the pieces come out after?
The only thing you have to remove, and you probably saw from nice comment.
Please call us.
Exactly. Once when you make a full depth cut, in order to bring the piece of wood fixed with the rest of the panel, the software has to leave tabs, which is another thing which is pretty common also in other CNC machines. And so we used to work that way. So you have to remove small pieces of wood of a few millimeters thickness in order to remove the piece you cut. Or on the other way, you can work with what it's called onion skin. So you can set the depth of cut with a few millimeters, leaving a few millimeters of wood. And in that way, you have a very thin layer of wood that you can remove, for example, with a hand cutter.
Can it ramp in and out? Maybe that's some lingo you guys know. I don't know what that was.
No, I think can it drive in 3 axes at the same time is what he's asking. Can it Z while it's Xing and Ying?
Not at the moment. On the mechanical side, the machine is ready to make it, and he manages because you saw that the Z axis move up and down, and it does also while it's cutting because it runs the cut in a spiral way. So, for example, the machine starts from 0 and if you select a depth of cut, for example, of 6 millimeters, it starts from 0 and at the end of the first round, it will reach 6 millimeters. So just to say that it's a thing that somehow already works that way. The big thing to make 3D projects is on the software. It's a thing we didn't develop at the moment. But again, based on the market request, it's an aspect we consider to make in the future as a further development for Slingshot.
Very, very nice. Well, Rick decided he had to leave, so that was that was phenomenal, guys. Like seriously, that was probably the coolest live stream we've ever had. Watching that from out of boxing all the way to a project, that is really, really. Thank you guys so much. Like that was unbelievable.
Thank you
for all the questions.
Thank you. That was pretty cool.
Well, we have one more here. We'll do one more question. The wheels don't slide with the material powder missing its cutting path. So, I mean, I didn't see any of the sanding powder was there or any kind of leftover dust. Or what do you guys have to say about that?
Even if there's some powder on the surface, it doesn't affect the precision in the cutting.
Wow.
Yeah.
And if it does slip, it can error correct. If it does,
Yeah.
I mean, if it should slip, it can error correct.
Yeah. If Goliath understands that it is not in the position it should be, a pop-up can come up on the software saying that there is a positioning error. So the bit will raise a little bit, so you will not damage the panel. Goliath will stop, so the user can check if everything is okay and restart by pushing the yellow button.
Cool. Any last questions from anyone there? Rick, Dan?
I'm thinking of all shops that spend a lot of money on hand routers and also the cost of employees lately. And this is just, it's almost too good of a solution to replace someone that is running a hand router, but also it's making it into a robot. It's taking away it's allowing a human to go do something else. And humans are hard to come by right now in our market. It's something you can set up and walk away from, and your parts can be done. Doesn't need to be a human there driving it. It's a cool solution, and I still go back to the idea of starting my own sign shop. I'm going to be thinking about that for the rest of the day. Lorenzo and Diletta, I can't thank you both enough for being here with us today. This was so cool to see the machine running and hearing from you two. And this was a great presentation. You two did awesome. Thank you very much.
Yeah,
Thank
without
you
a doubt.
for the space and the questions.
Yeah, you're welcome, Rick. Thank you for the opportunity.
Cool. All right. Well, thank you guys so much for joining us, and thank you guys for joining us. Thank everyone, gals, and everyone for joining us. Yeah, if you have any questions, be sure to hit up Aiken's Machinery over there now, or Hermit's Machine, or Wurth Machinery, which is Wurth Lewis and Company, all of the customers on the East Coast. We'll see you on the next Wurth Live coming out next month. And until then, have a good one.
Thank you, everybody.
Bye.